All right, welcome back. We're going to do another example. All right, so here it is. Suppose we want to do this integral, the integral of dx all over the square root of 16 minus 9x squared. And, all right, so that's the problem. Now, the thing is, we know how to do this one. The integral of dx all over the square root of 1 minus x squared. And the answer is inverse sine plus a constant. All right. So we can't use this integral formula because it doesn't exactly match our problem. There are two difficulties. So the problems, first of all, are that we have a 16 instead of a 1. And number two, we've got a 9x squared instead of, all right, x squared. Now we already know how to fix the second problem. It'll be a substitution thing, okay? We've seen that before. So let's go ahead and start with problem number 1 here, the 16. So we want a 1 there. And the basic trick is essentially just factor out that 16. So take that square root that appears in the bottom, 16 minus 9x squared. Factor out the 16 there. So it's 1 minus 9 over 16 x squared. And pull that out of the square root, so it comes out as a 4. 1 minus 9 over 16 x squared. All right, so now we've got the 1 the way we wanted, and this 4 that's in front is just a constant, and those will pull out of the integral. All right, so here was the original problem, the integral of dx all over the square root of 16 minus 9x squared, and what we did was just factor out that 4 in the denominator, like this, 1 minus 9/16 x squared. And as I said, that scalar, that constant, 1/4, comes out of the integral because it's a constant. So it changes it to this, 1 minus 9/16 x squared. All right, now this we know how to do. We wish that we had an x squared there. So what we are going to do is say, if only we had a u squared there, we'd be done. So let's let u squared be 9/16 x squared. In other words, if you take the square root, we're letting u be 9/16 of x. So du will be 9/16 of the dx when you take the derivative on both sides, du dx, and then move the dx over. So this problem over here comes down to 1/4. Now the du, well, we have a dx there, so another way to write this is dx is 16/9. Oops, I didn't take the square root, did I? It should have been 3/4, huh, when I did the square root. And so a 3/4 here. And when you solve for the dx, it'll be 4/3. All right, so that dx up here will just turn into a 4/3 of a du. And then that denominator will just be 1 minus u squared, because that's how we set it up. And now we pull that constant out, the 4/3, so it's the 4's will cancel. It'll be 1/3, the integral of du all over the square root of 1 minus u squared. And this one is dead on the money, so it's 1/3, the inverse sine of u plus c. And then we have to change the u back to the x, and u was 3/4 x. So we get 1/3 inverse sine of 3/4 x plus a constant. And that's it. All right. See you later. Bye.